Hi everyone, you're welcome to my YouTube channel. In this video, we are going to look at how muscles relax, muscle relaxation. I will start by talking about what muscle relaxation is not. Then we'll dig right in. First off, muscle relaxation doesn't occur necessarily because the myosin heads have detached from the active binding site on the actin. Because then again, it is a cycle. So until the event we are coming to talk about happens, that cycle of muscle contraction will continue in that particular muscle cell. What then is muscle relaxation? So as I have indicated here, it has everything to do with calcium ions. In fact, as long as calcium ions are exposed into the muscle cell, muscle contraction cycle will continue to take place. But as soon as calcium ions are actively pumped out back either into the sarcoplasmic reticulum or back into the ECF of the muscle cell or extracellular fluid medium of the muscle cell, then muscle contraction will continue. All right. So the events are majorly two. The factors that will lead to muscle relaxation are two. Muscle relaxation will take place if the concentration of calcium ions drop below 10 to the power minus 7 moles. In fact, as soon as this happens, what it tells us is that there is no longer a neural excitation of that muscle cell. So calcium ions are not actively pumped back into the muscle cell. So in this case, the calcium ions will be removed from troponin C. And I'll put the C here because that is exactly where the calcium ion binds to. So as long as there is no or enough calcium ions pumped into the muscle cell, or there's a drop in the calcium ion concentrations, then the muscle will prepare itself to relax. That's the first instance. Now, another thing that would cause the muscle cell to relax is coupled with the fact that calcium ion concentrations have gone down. There's also the troponin-tropomyosin conformational change. Now, what brings about this conformational change in the tropomyosin? It happens when calcium ions are removed from the troponin C. When the calcium ions are removed from the troponin C, then tropomyosin will immediately undergo a conformational change. That means that it is going to unwound itself, then it will again block the myosin binding site, which is an active binding site on the actin. Then this will cause the muscle to relax. So now let's look at the major events that happens in all these that I've talked about. I'm going to use this diagram to explain further. So let's look at this side. There was an arrival of an action potential. So this diagram coming down here is the arrival of an action potential. We can see this dihydropyridine receptor which couples the ryanodine receptor. Then calcium ions were pumped into the muscle cell. Now once calcium ions are inside the muscle cell, we know that calcium ions are going to bind to troponin C to bring about contraction. So in this stage, calcium ion binds to troponin C, the myosin head undergo hydrolysis as we learned in previous video, then they bind to the actin, bringing about muscle contraction. Alright, now as soon as this happens and the muscle is prepared to relax, these calcium ions have to be removed. So we have learned that the calcium ions would concentration would drop below a particular concentration level. When that happens, calcium ions will be actively pumped back in two ways. One of them is the use of this calcium ATPase. Now this calcium ion ATPase will make sure that these calcium ions are pumped back into the sarcoplasmic reticulum. In the same vein, some of the calcium ions will be using the calcium sodium pump or the calcium sodium ion co-transport to move 2 calcium ions out and 3 sodium ions in. In either of these two, calcium ions concentration in the muscle cell is going to drop drastically. Now look at the events that are happening here, and I want you to observe these two muscle cells carefully. Now look at the length between the Z disc for a contracted muscle and the length between these two successive Z disc for a relaxed muscle cell. And then look at the number of myosin heads that are not bound to the actin as compared to in a contracted cell. The fact that almost all the myosin heads are binding to the actin. Now this tells you that the removal of calcium ions will cause these myosin heads, which are cross bridges, to lose affinity or not to be able to bind to the actin. Once they are no longer able to bind to the actin, there will be no power stroke. In the absence of a power stroke, or in the absence of the binding of the myosin head to the actin, it means that the muscles has what? Relaxed. One significant thing about this is that if you observe the length tension relationship, for that matter, if you look at the sliding filament theory, again, look at a fully contracted muscle or a partially contracted muscle in this diagram. Look at the number which are concentrated here, the number of myosin heads which are concentrated in this region. If this is the length of the actin from here to this side and from this side to this side, we can judge that almost all the myosin heads in a partially contracted muscle are bound to the actin filament. But if we come up to the relaxed muscle, we can see that only a handful of the myosin heads are bound to this actin filament. And that shows how the relaxed muscle look like. Why is this happening? This is so because, remember, calcium ions have been removed. When calcium ions remove, then the myosin heads no longer hydrolyzes their ATP. So in this case, the myosin heads no longer have affinity for the actin. Another thing is that there is the increase in the length of the muscle cell. This is one Z disc as against another Z disc to show us that this is a complete muscle cell. So if you look at the distance between two successive Z discs, this relaxed muscle has an increased length as compared to a contracted or a fully or partially contracted muscle in which the Z discs are having a shorter length. So now you know the events that leads to muscle contraction, the events that leads to muscle relaxation. At the end of the day, for a fully relaxed muscle, almost all the myosin heads are not going to be bound to an actin filament, and so there is no tension that is going to be generated in this muscle cell as compared to a fully or partially contracted muscle where the binding of the myosin head to the actin would contribute to a power stroke, and that power stroke would generate tension necessary enough to overcome any kind of load. Alright, so this is the event that leads to muscle relaxation. Now, to sum up all that we have said, for a muscle to relax, first of all, calcium ions have to be removed. Just as calcium ion become the precursor for muscle to contract, for the muscle to relax, calcium ion have to be removed. The removal of calcium ion will cause the myosin head to lose affinity for the actin. That is to say that the active binding sites of the actin will also be blocked, so the myosin head cannot bind any longer. Now, when that happens, it means that there is not going to be any generation of tension in this particular muscle, and that is what relaxation is all about. Thank you for watching this video. See you in my next video.